All right. Good evening, everyone. Good evening, good evening. Good evening, Athar. Good evening, Varsha. One quick check with AV. Is everything good? Are we good here? Are we good with the AV here? Give me a heads up. Yeah. Thank you. All right, all right. All right, folks. Good evening once again. It's good to see you back. We'll continue with where we left. I guess in the last class we discussed about classification of numbers, how are numbers classified, and then we had one poke around divisibility tests. Then we did some questions on it. So we'll amp it up a little. We'll focus on one part, factors and multiples. To get into factors and multiples, you might have to remember the divisibility rules. Once again, that's important, obviously. And then the moment you know it, we add a layer to it, and then we start doing factors and multiples. And a lot of times factors and multiples also helps you in other questions. The moment you know how to break a number, it gets a lot easier to solve questions, trust me. There I have seen questions in arithmetic that uses numbers, and in those places if you know how to assess a number, it gets a lot easier. So we'll play around this for the day, and once we do it, we'll wrap it up. We'll call it a day. So to begin with, I want to start with one idea that we have learnt in all our school life, very specifically primary school. I'm pretty sure we all have done prime factorization. I understand that this is something that's quite basic, but some of us have gotten a little out of touch. So let's probably get some idea around it, and then we'll move forward. So what is prime factorization? What's the idea behind prime factorization? The idea behind prime factorization sits behind this word called prime numbers. One of the most important ideas when it comes to numbers is prime numbers. Why do I say that? We talk about numbers, we talk about products and sums, representation of a number. So when we come to representation of a number, prime numbers play a major role. When I say prime numbers, let's say 2, 3, 5, 7, 11, 13, 17, 19, to name a few. It keeps going on and on and on. What is the speciality of prime numbers? Any number in the system, call any real number, forget real, any natural number. Take any natural number for that case. Take that number, put it down, that can be represented as a product of prime numbers in a unique way. What do I mean by that? For example, if I say 6 can be written as 1 into 6, 2 into 3. When I say 18, you can write it as 1 into 18, 2 into 9, 3 into 6. There is a bunch of ways. I take a number, there's a bunch of ways that you can write it. But the best part about prime factorization is there are multiple ways to represent a number. If I take a larger number, I'm pretty sure there is going to be a lot more ways to represent it. But prime factorization gives you an idea of writing that number in a unique way. All numbers in the system, then all the natural numbers that we have, can be written in a unique prime product way. How is that possible? For example, if I take 6, 1 into 6, 6 is a composite number, I don't take that. 2 into 3. Is there any other prime combination that will give you 6? No. It's the only prime combination. 1, 2 and 1, 3, the product is 6. That's the only way that you can write 6 as a product of some prime numbers. Now when I go to this, now I don't want to write 1 into 18. Oops, sorry. I don't want to write 3 into 6. I'm looking at 2 into 9. I want to further break it down and then say, is there another way that I can write 2 into 9? I can break this 9. You cannot break 2 any further because that's a prime number. I can break this 9 and write it as 2 into 3 into 3, which is again 2 into 3 square. And there is no other way that you can write 18. 2 into 3 square is the only prime combination that will give you 18. If I make it 2 square into 3, that becomes 12. We understand that prime numbers can be written as a product of only one in itself. It has only two factors, only one in itself. One is the universal factor. Any number can be divided by 1. So I am not really worried about 1. But the other number that a prime number can divide, that a number can be divided by, for a prime number, it is itself. For example, if I think about 13, 13 can be divided by 1. 1 is called the universal factor. The other number is 13. So there is no other possible way of writing 13. So we break it down to prime numbers. That's what we call it as prime factorization. Simple idea that we all have learned, and this is a very powerful idea in combinations, in key combinations, for passwords. In a lot of places, prime numbers play a major role, a unique way. Remember this, any number can be written in only one prime factorized way. Any prime factorized way will have only one number. They are unique. If I say 2 square into 13, that can only be 12. 12 can be written in only one way, 2 square into 3. There's no other combination. It's unique, and that is why it is utterly important that we understand how prime factorization works. Because the moment you get an understanding about prime factorization, you are through with factors, you are through with HCF, LCM, you are through with one bunch of other ideas. It helps you to understand how a number is being formed. And remember this, we have infinite numbers, we have infinite primes. So the limit to a prime numbers is infinite. As a result, number system is also infinite. They both go hand in hand. I can add one more prime number. As a result, I can create one more number. I create one more number. As a result, I get one more prime number. It's an inevitable process that we are looking at. So get a hang of prime factorization, and we all have done this in our school once again. If I give you a number like 36, what is the prime factorization of 36? We do it this way, the L method, right? 2 is 18, 2, 9, 3, 3, and then 3, 1. So 18 is written as 2 square into 3 square. Well, that's how we all began. That's how we all began. If you are still following this, not a problem. At some point, you'll have to come to this mechanism. You look at the number, you know how to break it down. For example, if I give you 450 per se, 450, we shouldn't be doing it as 2, 225, 5, 45, 5. At some point, you have to cut it down and then say, okay, there are other ways that I can think about this. I can write 450 as 9 into 50. 9 can be written as 3 square. 50 can be written as 25 into 2. 25 will become 5 square. So that's 3 square into 5 square into 2. The order doesn't matter. All that matters is you get all of them right. Your mind has to come to that at some point. You cannot keep doing this L method all our life. It's not a crime. It's not wrong. But at some point, you'll have to adjust that mechanism and get to this. Any number that you get, you look at a number, your mind should have the comfort to break it down into prime factors, prime numbers. Come to that at some point, we are through, right? I want to have one quick look at the chart here. Business game plan is asking, is it raining here? It's not raining in Chennai. I don't know about the other parts of Tamil Nadu. Chennai, no. Sir, this is a question in the Quant book. Let m be the smallest natural number such that there are no prime form from m to m plus 12. Oh, there are no prime numbers from m to m plus 12. Might have to have a look at it. I think that's doable, but then I'll have a crack at it. M is the smallest natural number. There are no primes from m to. There is a gap of 12 numbers. Interesting. Interesting. The gap of 12 numbers, there are no primes. M could be a prime number. M could be a prime number. M plus 12 could be a prime number. Give me some time. I'll have a look at it. It's a comfort of numbers. I think I have to go a little further. We'll crack this. I think it's doable. Then we'll get to it. Right. I'm thinking about 115 to 127. 115 to 127. 117 goes in 3. 119 goes in 7. 121 goes in 11. 123 3 again. 125 5. Yeah, I think I have one. 115 to 127. 115 is a number. My m value is 115. And then I add 12 to it, I get 127. 127 is prime. But m to m plus 12, there are no prime numbers in between. That's the first number that I am hitting in my head. Okay. So 5m will become 500, 575 square. How do we do this? Malhotra, you don't do this. Yeah. If at all, if you ever happen to get this questions like these in CAT, you dump it. Yeah. I don't think how you solved it so fast. I have a comfort of number. I'm not even sure if 115 is the first number. I can think about something lesser. But then anything less than 100, there are 25 primes. I'm pretty sure every 10 has a prime. 1 to 100, every 10 has a prime. So first 100 is ruled out for me. 81. There is no 10s in the first 100 where there are no primes. So that's ruled out for me. So I thought maybe I have to go a little further. Then 101 to 113, can I think about that? 103 is prime, ruled out. 103 to 115, 105, 107 is prime, ruled out. 107 to 119, 109 is prime, ruled out. 111 to 123, 113 is prime, ruled out. 113 to 125, will that work for me? 113 is prime, 125 is not. 115, 117, 119, 113 works much better. 113 works. No, I will take 113, Malhotra. M can be 113. They didn't say M is not prime. The question says M is the smallest natural number. They didn't say M has to be composite. I will take 113. 113 is prime, but 113 to 125, there are no primes in between. I will change it. 114 should be, I will make an adjustment because the question has the point that both inclusive. I don't think your question read that way for me. Let me just have a look at it. M be the smallest natural number such that there are no prime numbers from m to m plus 1. Both inclusive. Sorry, I didn't read the last line. Then 114 to 126. Yes. Then 114 to 126. I thought I can take 113, but then I didn't read the last line. Great. It's someone's asking me how did I do this? The comfort of numbers. Now you have to understand, I've been doing this for a decade now, over a decade. I have one sense of comfort with numbers that has come to me over practice. It doesn't come to you overnight. If this question pops up in CAT, I would recommend you to dump it. I would do it. That's there in my zone. I would probably think about solving that question. Am I recommending this to you? Maybe not. It depends on how the comfort level that you have with numbers. Yeah, 114 to 126. Atharvias, 113 to 125, there is no prime numbers. 114 to 126, there are no prime numbers. But Priya Malhotra, she had that statement in the last which I didn't notice. It is clearly saying that both inclusive, it has to be no primes. So 114 to 126 is more suited. If that statement is ruled out, I would have taken 113. Right. A good question. I liked it. If it is there in the book, I would want to have a poke around it, but beautiful question. That was a thought in my head. Right. We'll get back to this. Are there any doubts with prime factorization in the first place? Prime factorization will also serve as a major part when it comes to HCF and LCM. So we'll also do HCF and LCM at some point. And then for today, we'll do factors and multiples. We'll get around it. Can we jump on? Right. I'm not going to do much today. I want to solve a bunch of questions, but the theory part for the day is very little, simply factors. Now I'm going to write down a bunch of 8 numbers here. I want you to have a look at them. I'll give you 3 minutes and there is a task that I'm giving you. I'll tell you what it is. You can take down the numbers. It's 15, 24, 40, 63, 7, 36, 49, 1. So I'm going to give you 4 minutes. I'm going to give you 5 minutes. The task for you is to find out the number of factors for each of these given numbers over here. There are 8 numbers on the board. Your task is to find the number of factors that each number has over here. How many factors does 15 have? 24, 63, 7 each. You can pin it down as one whole comment or you can put A, B, C, D. Give me the number of factors for all these questions. I'll give you 4 minutes time. Go for it. Folks, you are giving me the prime factorization. I'm asking you for the factors. For instance, if I say 15, okay, we will do it. I notice you folks have missed out on one set of numbers, but then I see some people giving me 15 has only 2 factors. Riya says 15 has 2 factors, and then anyone else? Okay, done. So obviously your theoretical way, your conventional way of doing it would be 15, you will write down the factors and then you will count them. So what are the factors of 15? Every time I say factors of a number, we always start with 1. So we start with 1, 3, 5, 15. So that's a total of 4. I talk about 24, we'll have 1, 2, 3, 4, 6, 8, 12, 24. That 1, 2, 3, 4, 5, 6, 7, 8. There are 8 factors here. 63, 1, 3, 7, 9, 21, 63. Yes, correct. 7 has 1, 7. This is 2, 3, 4, 5, 6 factors. 7 has 2 factors. Think about 36. 1, 2, 3, 4, 6, 9, 12, 18, 36. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 factors. 49 is 1, 7, 49. That's a total of 3. 1 has only one factor, which is 1. 64 has 1, 2, 4, 8, 16, 32, 64. 1, 2, 3, 4, 5, 6, 7. 7 factors. Right? Fifteen has 4. Yashika has, I think Yashika has gotten all right, at least with what I see now. Atharv has gotten it right. Yes, Atharv good. Varsha good. Nice, nice, nice. Great. Nice. Was it a good practice? Can I give you one more number? Can I give you one more number? Just one number, shall I? Yes, yeah. I was waiting for that. Yes. So the number that I want to give you is 3,600. Start writing now. But we'll probably finish it by the end of the class. By the time you write it, start writing 1, 2, 3, 4 work, yes 4 works, 5, 6, 8 works, yes 8, 9, 10, 12, 15, 18, 20, 24, will 24 work? No, 24 will not come. 25, yes 25, 26, 27, no. 28, no. 29, no. 30, no. 32, no. 35, 36, 40, 45. Nice, right? It will be time consuming. Exactly. Cannot keep writing all those numbers. And we are very certain of the fact that we'll miss out on one bunch of numbers, right? Is this the way to do it? Definitely not. So there has to be a simpler way, there has to be a better way to do it. Do we have one? Yes. It's a much simpler way to do this, and we'll think about it. We'll have one address about it. But then before we go to that, look at the number of factors these numbers have. The numbers that I have written in the board, on the board, I've written those numbers in that order for one particular reason. Look at the number of factors over here. And I want you to see if you see a pattern in it. Is there any connection to the numbers? Is there a pattern to the number of factors that we are looking at? Let me know if there's any. Riya Malhotra is asking, is 24 the answer? No, not even close. Not even close. 24 will work. Oh yeah, 24 will work. Yes, yes. 24, yeah, 24 will work. Sorry. See. Even I will miss out. To err is human, man. Yes. Now, is there a pattern that you see here? Look at the factors. This has 4, this has 8, this has 6, this has 2, 9, 3, 1, 7. Do you see a connection with the number of factors? Do you see a connection with the number of factors that these numbers have? Can anyone point it out? And this is super important. This is super important. I want you to see if there is 15 as 4, 24 as 8, 6 as 60, 63 as 6, 7 as 2, 36 as 9, this has 3, 1, 7. I want you to see if you spot a pattern. Look closely. There is some connection. There is something. The way that I have written them, they go in some groups. I'll make it a lot easier for you. Look at the first 4 numbers as one group, second 4 numbers as another group. Now see. Now check this out. Look at the first 4 numbers as one group, the second set of 4 numbers as another group. Riya says square root plus 1 multiple all of them. Not really. 24 doesn't even have a square root. 64 doesn't have. No. They're close but not really. Look at the number of factors here. 4, 8, 6, 2. Do you see a connection to that? 4, 6, 8, 2. Look at the second set of 4 numbers. 9, 3, 1, 7. I've given it to you now. The first set of 4 numbers have factors, number of factors as 4, 6, 8, 2. The second set of 4 numbers have number of factors as 9, 3, 1, 7. Some connection here. Can't explain in text. No, you can, Riya. This is something that you can explain in text. I don't want to give it away straight away to you folks. That's why I'm waiting. I would wait for even another 3 minutes for you to figure it out. Varsha, absolutely. Suraj, Varsha, perfectly right. Look at the number of factors for these 4 numbers. They all are even. Look at the number of factors for all these numbers. They are all odd. Oops, okay, I don't have space. Okay, fine. The first set of 4 numbers, the number of factors is even. Second set of 4 numbers, the number of factors is odd. Is there a connection to it? Yes. Look at these numbers now. 36, 49, 1, 64. They all happen to be perfect squares. With this, can we come to the conclusion that number of factors for a perfect square will always be even. For a non-perfect square, will be odd. And that is a super important idea that we follow. I'll tell you why. And this idea is crucial. But before we go to this, we all might have this question. Hey, why does a perfect square have odd number of factors? Why doesn't a perfect square have odd number of factors? Why? Why does this group follow this pattern and why does the other group follows another pattern? The answer lies in the question. When you go to the number, we'll do a drill. Now when I say 24, I want you to write 24 as a product of any two numbers. Product of any two numbers is 24. What are the possible combinations that you can make? We can make 1 into 24. For you to make a product 24, we understand that we should take numbers that are factors of 24. If I say a into b is equal to 24, where a and b are integers, we have to say a and b are factors of 24. There are no other ways to create 24, right? So 1 into 24 will work, 2 into 12 will work, 3 into 8 will work, 4 into 6 will work. All the factors will make a pair. They pair among themselves, and hence every set has two numbers in it. It will always be 2n. It will always be even, right? The number of factors is even because the numbers can be created by a pair of two numbers. It has to be even. It's no other way. But when you look at a perfect square, let's say a number like 36, what are the combinations of making 36? 1 into 36, 2 into 18, 3 into 12, 4 into 6, 4 into 9. But 6 is like Salman Khan, forever single. It doesn't have a pair. It will never have a pair. It doesn't, it won't. 6 will pair with itself to give you 36. All the other numbers has a pair. 6 has a virtual pair called 6 itself. Every square has a pair which is the product of its square root. 49, 1 into 49, 7 into 7. 7 doesn't have a pair. 64, 164, 232, 416, 8 into 8. So as a result, there is one number that's being left out. As a result, for a perfect square, it will always be odd. For a non-perfect square, it will always be even. Super powerful idea. It works in a lot of places. We also use it in a bunch of questions. To remember this idea is utterly important. We'll go to it. Any doubts with this question? Vasha, I think he wrote that by mistake. Where? Oh, did I? Oh, sorry. Sorry. My bad. This is odd. My bad. I was saying, but then I wrote the other one. So two different parallel minds working at a time. Any doubts up until this point? Aryan, sorry. My bad. Thank you for spotting it. It's important. Any doubts here? Now can we go back, revisit this number? I want to take this 3600 and find the number of factors for it. Shall we? How do we do it? Step 1, standard format, 3600. Step 1, prime factorize it. PF is not provident fund, PF is prime factorize it. Prime factorize 3600 and let's get that value. How do I prime factorize 3600? I can think about this as 36 into 100, 6 square into 10 square, 2 into 3 the whole square into 2 into 5 the whole square, 2 square into 3 square into 2 square into 5 square. So 3600 will have 2 power 4 into 3 square into 5 square. You cannot have 2 square and 2 square. You cannot have 6 square into 2 square into 5 square. All the numbers in the further limit has to be broken down into prime numbers, and all prime numbers of one kind should be clubbed together. There's a 2 square here, there's a 2 square here, I'll call it 2 power 4. You cannot call it 2 square into 2 square. That has to be 2 power 4. Right? This is your first step. Step 1, prime factorize it. Step 2, add 1 to the powers. add 1 to the powers. Look at the power, take them out, add 1 to them. So 4 plus 1, the next one will be 2 plus 1, and then the other one will also be 2 plus 1. Right? That's step 2. Step 3, multiply. I'm calling it steps, but it's not even 3 steps. It's not even a 3-step thing. Prime factorize, add 1 to the power, multiply it. We'll get 5 into 3 into 3, 45 factors. The number of factors was 3600. That's 40. We have it. Right? Any doubts? Now, usually, some people ask me a question here. That's a genuine, legit doubt that can come inside your head now. There's a beautiful doubt that people ask me every now and then, every time I do this, and it is a legit, valid doubt that you can have in your head. If you have that question, shoot. If you don't have that question, we'll go to the questions. So can we use this for any number? Any number, any natural number. If the question says number of factors, that's how you do it. Any number, irrespective of whether it's a prime or a composite number, that's the way. Clear? Beautiful, beautiful. Varsha has spot on. I like that question every time it pops up. Why are we adding this 1 to the powers? Why? How many of you have that question the moment you hear it now? Now Varsha has pointed it out, but how many of the others have this question in your head? Why are we, everything seems fine. Out of nowhere, where did this 1 come from? All seem to be fine. Factorizing it is fine, multiplying is fine. Where is this 1 coming from? Anyone else having that number? Anyone else? Used to any rational number, natural number. I am more specific. Rational number can also be decimal, Satar. When you say rational number, 45, 4.5. 4.5 doesn't have factors. You cannot call it factors. The moment you get to decimals, there are no factors for it. You can call it 2.25 into 2. You can call it 0.5 into 9. But it doesn't work. You can write a million ways then now. So that's why every time we talk about factors, we talk about multiples, we are talking about natural numbers. Even for that fact, I'll go to integers, because you can also think about -2 into -3. We don't call -2 -3 as factors, but then that's okay. Product of 2 integers, multiple, fine, that's fine. But the entire idea of factors goes around only natural numbers, not rational numbers. Is it because 1 is also a factor? No. Yeah, not even close. We all think about it. 1 is a universal factor. Maybe that's the reason. No, that's not the reason. I'll solve a question. I'll probably go. I want to go to the first. Fine. I'll tell you why this 1 is being added. To explain this idea to you, I'm going to take this number 36. Then I'm going to say, how many factors does 36 have? We will say 36 is 2 square into 3 square. So 2 plus 1 into 3 plus 1 is equal to 3 into 3, that's 9 factors. Right? Simple. Let's do a activity now. So when you say 2 square is a factor, we understand that 2 is also a factor. 2 power 1 is a factor. When I say 2 power 1. 2 power 2 is also a factor. 2 power 1, 2 power 2. Similarly, 3 power 1, right? We also understand any combination of 2's and 3's here will also be a factor of 36. We'll list down the factors then. 1, 2, 3, 4, 6, 9, 12, 18, 36. Right? Any combination of the 2's and 3's here should also be a factor, right? So we'll do all the combinations now. What is 2 power 1 into 3 power 1? 2 power 1 into 3 power 1 is 6. Do we have a 6 here? 2 power 1 into 3 power 1? 6. Yes. 2 power 1 into 3 square? 9 into 2 is 18. Do we have an 18? Yes. 2 square into 3 power 1? 4 into 3 is 12. Do we have a 12? Yes. 2 square into 3 square is 36. Do we have a 36? But where are the remaining factors? How do I carve out the remaining factors from here? To do that, all I'm going to do is add a 2 power 0 and a 3 power 0. Why? When you say 2 power 2 is a factor, 2 power 2 is a factor, 2 power 1 is a factor, 2 power 0 is also a factor. What is 2 power 0? What is 3 power 0? So the combinations of 2 power 0 and 3 power 0 will also give you factors. Now let's see if all the factors are being brought out. 2 power 0 into 3 power 0, 1. 2 power 0 into 3 power 1, 3. 2 power 0 into 3 square, 9. 3 power 0 into 2 power 1, 2. 3 power 0 into 2 square, 4. Did we carve out all the factors now? Yes. And how did we do that? By including one additional power of 2 and one additional power of 3. That is the plus 1. So when you say 5 power n is a factor, 5 power n, the highest power of 5 is 5 power n, there are n plus 1 values of 5 that I can think about. So to incorporate the power zeros, we add the plus 1. The generic rule that we say is, if any number is of the form n is equal to a power x into b power y into c power z, the number of factors is equal to x plus 1 into y plus 1 into z plus 1. Very importantly, a comma b comma c are distinct prime numbers, not just any prime numbers. They have to be distinct prime numbers. Are we clear? Any doubts? Beautiful. Mark it down in some place. Such a powerful idea. The moment you look at it, everything that we see in factors and multiples is carved out of this now. Are we clear? Any doubts? I'm going to have one quick look at the question chat here. Are we good here? We'll do one set of questions. I'm not just going to do only the factors part. I'm going to add layers to it. Every time I add a layer, I'll also tell you how it is done, why it is done. I believe it is more important to know why a certain thing is done than how it is done. I would happily say this is the formula, follow it. I want you to know why this is being done. Why is this plus 1 happening? How should I substitute it? How should I plug into this idea? How do I break this from to another idea? All of that happens when you have your foundation strong, right? So we'll do one set of questions now. Right, I'll give you this question. Think about this now. Now we had one basic idea about it, but then go to this question. What makes a number a perfect square? Think of that. That's the clue. The smallest positive integer that must be multiplied with 306 to make it a perfect square. How do I get a perfect square in the first place? Oh, any number, let's go back to this 24, we had 24 in the previous case. Will you say 24 is a perfect square? You look at 24. Is 24 a perfect square? You look at it, you know the bunch of squares, you look at 24 and then you say, hey, 25 is a perfect square, 16 is 1. 24 doesn't look like a perfect square, you will happily say that. But mathematically, when do I know a number is not a perfect square? Once again, goes to the idea of prime factorization. When you do this, that becomes 2 cube into 3 power 1. Now let's take 18. 18 is 2 into 3 square. When I take 12, that's 2 square into 3 power 1. Now, if I have to make all of them perfect squares, now let's take one more number, 64, which is 2 to the power 6. You look at 36, 2 square into 3 square. I'm writing some familiar perfect squares that we know. If I have to take 144, 2 power 4 into 3 square. If I have to take 900, that will be 2 square into 3 square into 5 square. Obviously, I look at all these numbers, they all are perfect squares. These are not perfect squares. What makes a number perfect square? The idea once again lies with the fact that look at the prime factorization and that holds the key. And what is that key? The powers, all the powers, only when all the powers are even, the number becomes a perfect square. This is a perfect square. Look at this. All the powers here are even. All the powers here are even. Right? Here, this is not even. Here, this is even. This is not. Here, this is even. This is not. Even if the power of one prime number is not even, the number is not a perfect square. In that case, if you have to make this a perfect square, what do you have to do? You have to multiply it by a 2. You have to multiply it by a 3. Why? Only then this will become 2 power 4 into 3 square. 2 power 3 into 2 power 1 will become 2 power 4. 3 power 1 into 3 power 1 will become 3 power 2. And that becomes a perfect square. Here multiplied by 2. Here multiplied by 3. Simple. That's the idea. Look at the power of the prime number that you have. Make it a perfect square. Make it even. The number becomes a perfect square. Plug in this idea to 306 now. So when I look at 306, goes nicely in 36 for me. So this will be 6, 306 goes in 6 for me. 6 into 51, 17 into 3. So that is 2 power 1 into 3 square into 17 power 1. I'm not worried about this because this is a perfect square. But I still need one more 2 and one more 17, or I have to multiply it by 34. 34 is your answer. Right? I'm looking at the chart here. Smallest positive integer is 34, 34, 34. Everyone saying 34. Absolutely. Perfect. Are we good with this now? Any doubts? Priya, Varsha, Aryan. Anyone else, if you have a doubt, if you have a question, let me know. Any questions? Now, what do you have to make? What should you do to make a number a perfect? Let me make one small change here. Instead of 306, let me say 270. What is the smallest positive integer that must be multiplied with 288 to make it a perfect cube? Just an activity. Just an activity. I want you to make 288. What will you multiply with the 288 to make it a perfect cube? Attack it. I'm just adding one layer. I thought of sticking with one question, but then I felt like, hey, let's do a layer of it. Right, I'm getting the answers now. Let's do it. 288. I look at 288. Beautifully goes in 9 for me. 9 into 32. 39 is 3 square. 2 to the power 5. 32 is 2 power 5. Now, how do I make a number a perfect cube? Very simple. The powers should be a multiple of 3. It has to be a multiple of 3. For a number to be a perfect power of 4, all the powers should be multiples of 4. So since I say it's a perfect cube, the powers have to become cubes. So had this been 3 power 3 and then 2 power 6, this is a perfect cube. Why am I calling it a perfect cube? Because I can take out the 3 common. I can write this as 2 square into 3, the whole power 3. Whatever number this is, power 3 is a perfect cube. So what should you multiply this with? Multiply it with a 2, multiply it with a 3, or instead multiply it with a 6. Clear? Be very clear with the fact that the powers have to be multiples of n for that to be a perfect power of n. Right? Any doubts? Are we good with this now? Are we clear? Shall we hop on to the next question then? Right, there are 4 questions. We have done all these ideas. Simply find the factors of all these 4 numbers on the board. I'll do all 4 in one stretch. We'll do this. I'm not going to waste a lot of time doing these questions now. I've gotten the idea of how it's done. So 100 100, that's 2 square into 5 square. So that's 3 into 3, that's 9 factors. I'm going to skip steps. So I've gotten used to it now. 72, 3 into 3. I'll write probably 3 into 3. 72 is 8 into 9. So that's 2 cube into 3 square, which will be 4 into 3, 12 factors. 148. 148 goes nicely. 75 into 2, but 74 into 2. 74 is 37. 2 square into 37. 37 is prime. So that's 3 into 2. That is 6 factors. 450. 45, 10. 5 cube. 3 square. Oh no, not 5 cube. 5 square. 225. 5 square into 3 square into 2. Am I right with this? 9 into 25 is 225 into 2 is 450. So this is 3 into 3 into 2, 18 factors. Right? 9, 12, 6, 18. 9, 12, 6, 18. 9, 12, 6, 18. Atharv and Riya has gotten 24 for the last one. Both of you have gotten 24 at the last one. Getting 18. I have an inclination that I have gotten it right. 25 into 9 is 2. 25 into 2 is 450. I think it has to be 18. Riya and Atharv, have one look at your calculation. Maybe something has gone wrong. And that's fine. We'll get that. We'll jump to the next one now. Go for this. Nice question. Might look like, hey, you didn't teach us this type of questions. I did. Have a look at it. Solve it. We'll discuss. Right, we'll do this. The question sounds a little different. All this while we were finding factors, and all of a sudden it says, in how many ways can the following numbers be represented as a product of two distinct natural numbers? Right, we'll go to this. First we'll look at 96. We'll try to write, we'll probably do it for a smaller number, and then we'll see, is there a way to crack this idea and then get through. I'm going to take a number called, let's say 48. Let's say 48 is a number. What are the possible ways to write 48? 48 can be written as 1 into 48. You can write it as 2 into 24. And write it as 3 into 16, 4 into 12, 6 into 8, and then 8 into 6, 12 into 4, same. This is the same as this. I'm looking at this and then I'm noticing that there are only 5 ways. And then comes my question, why there are only 5 ways? And then I realized there were only 10 factors. Since it has only 10 factors, I can write it on only 5 combinations, pairs of two distinct natural numbers, right? So maybe this is taking me to somewhere. Maybe it is telling me, hey, if you know the number of factors for the number, you can tell in how many ways can they be written as a product of two distinct natural numbers, right? So can I use the same logic over here? 96 can be written as 3 goes of 32. That is 2 to the power 5 into 3 to the power 1. 6 into 2, that is 12 factors. All I'm going to simply do now is 12 divided by 2, 6 ways. Right? Isn't that easy? So when do you know it? We are through. 6 ways. Why 6 ways? There were only 12 factors. All the 12 factors, each 2 of them will make a pair, giving us only 6 pairs. So there are only in 6 ways where you can write 96 as a product of two distinct natural numbers. Are we good here? Any doubts? Is 9. Right. We'll go to 324 now. Then think about 324. So what does 324 do now? 324 is 18 square. 18 square is 2 into 3 square, the whole square. That is 2 square into 3 to the power 4. Or I can write this as 3 into 5. 15 factors. So what do I do? 15 by 2. But 15 by 2 is 7.5. It's not an integer. It's a decimal. So should I take 7.5 as 7 or 8? Should it be 7 or 8? For this question, it is 7. Why? Why am I calling it 7? To give you an example once again, let's take a number called 36. 1, 2, 3, 136, 218, 312, 4, 9, 6. Now 36 has 9 factors. If I take 9 by 2, that's 4.5. But I can't take 4.5 ways. It's either 4 or 5. Which is right? That depends on the question. If the question says two distinct natural numbers, you have to write it in a form of 36 is A into B, where A and B have to be distinct. They have to be different. In that case, 1 into 36 works. 1 into 36 works. 2 into 18 works. 3 into 12 works. 4 into 9 works. 6 into 6 will not. Because A into B, they are not distinct. But had the question mentioned product of two natural numbers, in that case my answer would have been 5 ways. Why? It simply says two natural numbers. There's no condition on how the two natural numbers have to be. I can also take 6 into 6 into account. But since the question says two distinct natural numbers, it has to be only 4 ways because 6 into 6 will not work. So according to this question, 96 will be 6 ways. Is that 6? Sorry. Am I missing out on any other number? 1, 2, 3, 4. 48 is 2 power 4 into 3 power 1, right? That's 16 into 3. Someone said 6 ways. Pasha says 6. There's a bunch of people that say 6. 2 power 4 into 3 power 1. 5 into 2, 10. 5 ways. So for this question, this will be, this is 5. And this will be 7 ways because 15 by 2, 12 into 12, sorry, 18 into 18 will not be accounted for. You cannot take 18 into 18 because they are not distinct. Clear? Oh, question is 96. Sorry, I did it for 48. So 48. Oh, that shit. I did an example for 48 and then I took that number. So 96 is 2 power 5 into 3 power 1. So that is 6 into 2, 12 factors. That will be 6 ways. I'm sorry about that. Sorry, folks. Six ways. 7. I did 48 and then I did it also for, oh, here. My bad, I didn't notice. This late hour, man, happens. I did it for 96. 6 ways is the answer. So understand the concept that if the question says two distinct natural numbers, just look for the perfect square part. If it is a non-perfect square, you don't even have to worry about it. But the moment you get a perfect square, that we slightly worried about what does the question say. Does the question say two distinct natural numbers or two natural numbers, right? If it says two natural numbers, we also account for the square term. The square root product into product, a into a also works. If the question says two distinct natural numbers, you won't take the root product, right? Sorry. Sir, can we conclude that every perfect square will be represented as n by 2 minus 0.5? No, Swastik, that's what I said. N by 2 minus 0.5 works only if the question says two distinct natural numbers. If the question says two natural numbers, I will say plus 0.5. It depends. Read the question carefully for that. You cannot put it under one blanket and say any perfect square minus 0.5. No. It depends on the condition over there. Right? We'll jump on to the next one then. This question, this is slightly tricky. Find sum of all the factors of 720. Now we saw that you cannot list down all the factors. For you to find the sum of the factors of 720, the only way in our head as of now, it says that, hey, list down all the factors, add them all. But the exam will be over by the time you get the answer, and I can be almost certain that we are not even with the correct answer. Doesn't work. So that should be a simpler way to do it. Do we have one? The answer is yes. Now, for example, since 720 is big, I can straight away go to 720 and solve it, but I want you to understand why that idea works. So to do that, let me do an example question. Sum of factors of 12. Let's do the sum of the factors of 12. And from here you will do some of the factors of 720. I'm leaving it to you. You will solve it. Right. So what are the factors of 12? So first of all, let me write 12 as 2 square into 3 power 1. That's how we write it. So factors of 12, we can write it. Only 6 factors. 1 plus 2 plus 3 plus 4 plus 6 plus 12. Now we know that all these numbers over here can be written in some powers of 2s and 3s. We know that. How do we write it? 1 can be written as 2 power 0 into 3 power 0 plus 2 power 1 into 3 power 0 plus 2 power 0 into 3 power 1. I'll put them in brackets so that we don't get confused. Plus 2 square into 3 power 0 plus 2 power 1 into 3 power 1 plus 2 square into 3 power 1. Right? I've written all of them in powers of 2s and 3s. Now, what I'm going to do is, I'm going to take 3 power 0 common from this, this and this. And similarly, I'm going to take 3 power 1 common from this, this and this. The violet is not being nice. So let me use red. Right? We'll take 3 power 0 common from these 3 numbers. 3 power 1 common from these 3 numbers, and then we'll rewrite it. So how will you rewrite it? If you take 3 power 0 common from all of this, this will become 3 power 0 into 2 power 0 plus 2 power 1 plus 2 power 2 plus, if I take out 3 power 1 common from all of this, I will get 3 power 1 into 2 power 0 plus 2 power 1 plus 2 power 2. Now we can take this common out from both these expressions. You will get 2 power 0 plus 2 power 1 plus 2 power 2 into 3 power 0 plus 3 power 1. Now 12 is written as 2 square into 3 power 1. The sum of the factors is this. Now, do you see a connection? This entire part, I've rewritten it to this format. Do we see a connection? 2 power 2. And look at the powers of 2. 2 power 0 plus 2 power 1 plus 2 power 2. 3 power 1 means 3 power 0 plus 3 power 1. Simple. In that case, I can generically write this format. What would be the format? Any number of the form n, where n is equal to a power x into b power y into c power z. Once again, where a, b, c are distinct prime numbers, sum of factors is equal to a power 0 plus a power 1 plus a power 2 plus dot 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 up to a power x into b power 0 plus b power 1 plus b power 2 dot 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 up to b power y into c power 0 plus c power 1 plus c power 2 dot 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 up to c power 0. That will be the formula. I am not only telling you the formula, I'm also telling you why. Right? Any doubts? Now I'll give you 2 minutes. Find the answer for 720. What will be the answer for 720? We'll do this now. 720. First, let's factorize 720. Can write it as 40 into 18, but 72 into 10. So that is 2 cube into 3 square into 2 into 5. 5. So that will be 2 power 4 into 3 square into 5. 16 into 5, 80. 80 into 9, 720. Perfect. So sum of factors 1 plus 2 plus 4 plus 8 plus 16. 16 is 2 to the power 4 into 1 plus 3 plus 9 into 1 plus 5. 5 power 0, 5 power 1. So this adds up to 31 into, that is 13 into 6. So 31 into 78. 31 into 80 is 2480. 2480 minus 62. 2420. 24. Am I good? Am I right here? 2418. Bingo. Hope now you know how sum of the factors is found for any given number. That is how it's done. That is why it is done that way. Are we good? Oh, that was interesting, right? It's good. It's always nice to know why we are doing a certain thing, right? Brilliant. We'll do one last question and wrap up for the day. Go for this. Now we did sum of factors. We'll do product of factors. Go for it. Go for it. Product of factors. Find the product of factors of 60. Do it. We'll wrap up with this now. Find the product of all the factors of 80. Once again, let's do an example question. And from there, we'll see if there is something that we can extract and then apply it for 80. And again, do it for 12. 12 is slightly easy for all. Let's do 18. So, product of factors of 18. So, product of factors of 18. So, what are the factors of 18? 1, 2, 3, 6, 9, 18. Again, you will think like, okay, let's also prime factorize every number and see where it takes us. You will get this to be 2 power 0 into 3 power 0 into 2 power 1 into 3 power 0 into 3 power 1 into 2 power 0 into 2 power 1 into 3 power 1 into 2 power 0 into 3 square into 2 power 1 into 3 square. I'll think like, okay, let's club all the 2's and 3's together. If this is what your head is doing, you're good, you're in a good track. Then let's do this. So how many 2's are there? There's a 2 power 1, 2 power 0, 2 power 1, 2 power 0, 2 power 2, 2 power 0, 2 power 3. It's a total of 2 power 3 into 3 power 0, 3 power 0, 3 power 1, 3 power 2, 3 power 4, 3 power 6. 2 cube into 3 power 6. That's what we are getting. And 18 is 2 into 3 square. But I am getting 2 cube into 3 power 6. Our minds will say, hey, you might probably have to cube it. But if I ask you the product of the factors of 8, that's 1 into 2 into 4 into 8, you will get 2 power 1, 2 power 2, 2 power 3, that is 2 power 6. Seems to be like, maybe there is some connection, right? That's how we do it. This is 8 is 2 cube, but the product is 2 power 6. Maybe square it here, maybe cube it here. I don't find a correlation. Maybe all this while we were right, but except for one step. Maybe I could have broken it down into a simpler way. What I'm going to do is, I'm not going to do it this way, but from here, I'm going to slightly rewrite it in a format that we are comfortable with. What is it? I'm going to rewrite this, the same one, in a different order. I'm going to say 1 into 18 into 2 into 9 into 3 into 6. Am I right? 1, 2, 3, 6, 9, 18. Same 6 factors. But I've written them in pairs. What is 1 into 18? 18. 2 into 9? 18. 3 into 6? 18. Or can I say the product of the numbers is 18 cube? Now comes the question, why am I getting 18 cube? Because 18 has 6 factors. The 6 factors can be written in pairs of 2 numbers thrice to get me 18, or in simple words, I am multiplying 18 3 times. The same idea is going over here. 1 into 8 into 2 into 4, or 8 into 8, or that's 8 square. The product of all the factors of 8 is 8 square, which is 64. Or in short, once again, product of factors of, let's say, n, capital N, is equal to n power n by 2, where small n is number of factors. That's all. Product of factors of a number capital N is nothing but n power small n by 2, where n is the number of factors of n. Clear? Any doubts? Now can you do 80? I want you to do 80 now. Go for it. So what would it be then? 80 is nothing but 2 power 4 into 5 power 1, which is 5 into 2, that is 10 factors. So 10 factors means I can write it as 5 pairs. So the product of all the factors of 80 is nothing but 80 to the power 5. I don't know what 80 power 5 is. 0, 0, 0, 0, 0. 8 power 5 is 2 power 15. Am I getting somewhere around 2 power 8 is 256. 2 power 16 is 65536. 32,000. 536. 768. Am I correct? 3276. 788. 768. 768. Bingo. I'm good. I haven't lost. I'm still worthy. 3276. But then you don't usually get this as answer. You'll probably get it in parts. You don't get 80 in the first place. Clear? We are also getting the same. I got the same. We are on the same page. We are correct. Right? Any doubts, folks? Before we leave, same question. I'm going to add one layer. Instead of 80, I want you to do 144. But 144 will stop. No, not 144. 144, you might have to give me the value. Okay, fine. Let's do 144. Sorry. Same question, 144. I don't need the value. Just tell me the expression. Don't give me the value. Harsha says 14 raised to the power 8. Okay. Okay. Aryan acknowledges saying that's 14 raised to the power 8. Riya Malhotra says 14 raised to the power 8. Sorry, 144. Sorry. 144 raised to the power 8. I'm happy that everyone's getting 144 per 8. Everyone's getting, no doubt, everyone's getting 144 to the power 8. Are you getting 144 to the power 8? Everyone? Did everyone get 144 to the power 8? Bravo. Brilliant. Unfortunately, that is not the answer. Now, why did you take 144 to the power 8? Because you would have noticed that 144 is equal to 2 power 4 into 3 square, which is 5 into 3, 15 factors. And then you will say, hey, I get 7.5, but 12 is also a factor. So I am accommodating that. So I am making it as 8 pairs. We all did that, right? Yes. Yes, everyone did this. You got 7.5. But then you said, hey, 12 is also a factor. So I'm also taking that pair. So 8 pairs. But did you realize when you take the 8th pair, you are not taking one 12. You are taking two 12s in it. Did you notice that? Do you realize that now? Yes. When you take the 8th pair, I'll give this with an example. We'll do it for 36. 36 is easy for me once again. 36 has been my standard number to give examples for anything. So when I do it for 36, you'll say 1 into 36, 2 into 18, 3 into 12, 4 into 9, and then you also happen to have 6. 6 into 6 is there. 1, 2, 3, 4, 5, 6 pairs. The sixth pair has one additional 6 sitting in it. Can you take this pair? No. You can take only the 6. You can take only the 6. You cannot take the other 6. You took another 12 here. That's why 14 bar 8 is incorrect. So let's see what the right answer is with 36. Now you will get back to this now. So can I write this as 36 into 36 into 36 into 36 into 6. You cannot take this one. You can take only 1 6. Can I write this as 36 into 36 into 36 into 36 into 36 power 1 by 2? Instead of 6, can I write this as 36 power 1 by 2? Now can I add all the powers? This will become what? 36 power 4. Now this is the formula irrespective of whether it is a prime number, whether it is a perfect square or a non-perfect square. It doesn't matter. So the answer for this is not 144 power 8, it is 144 power 7 into 12 or 144 power 7.5 only. Clear? That's 144 power 7 into root of 144. There's a 12 sitting separately. Or you can straight away write it as 144 power 7.5, which is also right. You can write it as 15 by 2. That depends, that's your choice. But it's not 8, it's not 7, it is exactly 7.5. This formula holds good, irrespective of whether it's a perfect square or not. Right? Now you know why it's not 8. Are we good here? That's how it's done. Know your factors well, know your multiples well, have a grasp of it, solve questions, check your DPP, solve them, get the comfort of solving it over and again. Any questions, any doubts, feel free to shoot it in the comments. We'll always be there to help you out. We'll stop here. Remaining ideas, we'll discuss it in the next class. We'll sign off for the day. Thank you for showing up. Have a great weekend, folks. Thank you. Got any doubts? Shoot. If not, we are done. Thank you. Thank you. Ria says that you have a, yeah, shoot Ria, shoot your question. Understood everything very well. Yeah. I'm glad you did, Yashika. I'm glad. Not able to find the Telegram, my Telegram group. How can this happen? Yeah. That's the QR. Aryan says we really enjoyed the session. I'm glad you did. I'm glad I was able to keep you lively at 10:30. Not a math problem, moreover mentor problem. Go, shoot it. Have a question, shoot it. Pasha, that's the QR. You can scan it. That will take you to the group. Next class will be on Tuesday. We'll have a session on Tuesday. You will happen to see me every Tuesdays and Thursdays. Sorry, Tuesdays and Saturdays. My bad. Sorry. Your classes, your sessions with me will happen on Tuesdays and Saturdays. Sorry. I'm preparing for both UPSC and CAT. So how should I do the quant and LRDI syllabus? LRDI syllabus is same. When it comes to quant, I really don't add on anything. However, you are preparing for CAT, your prep strategy remains the same, except for the fact that you have to work on your time management, where it is slightly different when it comes to UPSC. So you'll have to adjust to the exam pattern and your solving speed. They take a shift, but when you do CAT, you have to understand that you are doing a little more advanced math for UPSC. Your CAT strength on your funda definitely secures you your quant syllabus for UPSC, undoubtedly. But then you have to understand, you are preparing UPSC. To give you an analogy, UPSC is like 11th grade math, CAT is like 12th grade, so slightly less, only when it comes to quant or DILR. So you might have to adjust your speed and then your exam pattern comfort. Apart from that, there is nothing much that you might have to do. Rest all, when you do your CAT quant, are pretty much covering ground everywhere. DILR, the ball game is slightly a lot different. You get logical reasoning than data and DILR CAT DILR is slightly different from what you do in UPSC logical reasoning. That's called logical reasoning. Those questions are simple, a lot simpler than what we see. Syllabus, once again, syllabus is same. The pattern, question pattern, time management, they all differ. Your DILR for UPSC, when you do CAT, you have to understand you are doing a lot more. There are other components of UPSC that you are missing out, like syllogisms, blood relations. You might have to focus on that coding, decoding, analogy, number series. You might have to focus on these parts also. Have a go at that. That should also help you, right? Is this okay to aim for 2 competitive exams? Yes, definitely. Yes, definitely yes. But then the adjustment is something that is internal, not on the syllabus part, not on the how do I put it around. It's a mental thing. You might have to take more mocks over there as well. Realign yourself to that. But I mess up with numbers when I speed up. That's what I've been telling over and again. Accuracy over speed any given day. You don't focus on building speed. You focus on building accuracy. Speed comes on its own. It's a natural process. The transition happens organically. Stop comparing yourselves with people doing super fast math. For example, I did a bunch of math here without even having a calculator. I'm super comfortable doing it. That should not be the bar. You cannot compare yourself with someone who's doing at a good pace. You tell yourself, I'm in a learning stage. I have to improve my accuracy. My speed will come on its own. So the fumbling part happens. Wait, it takes time. You've started your prep now. You don't master it in 2 months. It takes months. It takes years. It took me years. I'm still a learner of this subject. It takes me time. I made mistakes. You saw that. I make mistakes. We all do. Hang on. Tell yourself you will get there. All right. Thank you then. We'll stop here. It's nice meeting you once again. Thank you for staying back. We'll see you in the next class. Good night. Thank you.